In the mountains of Yamanashi, there's a house built in 2022 with no nails, no screws, and almost no metal at all. It sounds like it shouldn't hold up, but it does. It's called 8-Mado, built by Sobokuya. Every piece of wood is cut to lock into another, holding the entire structure together. With basic upkeep, it could last for decades, maybe longer, and that method has a long history behind it. In Japan, there are wooden buildings that have stood there for more than 1,300 years of earthquakes, with just wood locked into itself by shape alone. Most buildings don't last a century. These have lasted 13. So how is that even possible? Wood and earthquakes don't mix. So why are these buildings still standing? To find out, we must go back to the late 6th century and follow a carpenter who left everything he knew. He was one of 3 master carpenters who crossed the sea from the Korean kingdom of Baekje, each carrying a way of thinking about wood that their civilization had spent centuries refining. We know him as Kongo, though that name is known more through tradition than records. What we do know is that when he arrived in Japan, he made a choice that changed the course of Japanese architecture. Of those 3 men, Kongo didn't go home. He stayed, he built, and he opened a workshop, taking on apprentices and passing down everything he knew. Those apprentices passed the knowledge to their apprentices, and they to theirs. And eventually, 2 special buildings were produced. They were so extraordinary that one has been standing for over 1,300 years, and the other has been deliberately destroyed and rebuilt more than 60 times, preserving techniques across centuries. But to understand what the carpenter brought, we need to understand the problem he was trying to solve. Wood moves. It swells in rain, contracts in cold, creaks under load, and slowly yields to the insects and moisture that are always patiently working against it. Every civilization that has ever built in timber has had to answer the same question. How do you hold the wood together? Most countries reached for the same answer. Metal, nails, pins, bolts, straps. Fix the joint rigid and the structure holds until the force exceeds what it can handle. You see, instead of flexing and spreading the stress, rigid joints can concentrate force at specific points and are more likely to fail under extreme pressure. Think of a plaster cast on a broken leg. It holds perfectly until the force against it is too great, and then it shatters. The tradition the Baekje carpenter carried had reached a different answer, and that answer began with 2 simple shapes. Take 2 pieces of wood. In one, carve a precise rectangular cavity into the body of the beam. This is called the mortise. Shape one end of the second piece to fit that cavity exactly. This is the tenon. Slide the tenon into the mortise, and what you have created is a joint that holds itself together through geometry alone. Some of these joints are cut with a slight taper so the fit actually tightens under pressure. But the real innovation is what happens when force arrives from the outside. When an earthquake shakes the ground or a storm pushes against the walls, a metal fastener holds rigid until it breaks. The mortise and tenon joint does something different. It moves, compresses slightly under load, and returns. It allows the structure to absorb movement and helps spread stress more evenly, reducing the chance that any single point takes enough force to fail. Replace the plaster cast with a flexible brace. The brace allows controlled movement within a safe range. It absorbs, it distributes, and it does not shatter. That's the difference. One holds until it breaks, and the other just moves. Achieving this precision requires a secret tool, one most Western carpenters would find completely counterintuitive. The Japanese hand plane, called the kana, is pulled toward the body rather than pushed away. This gives the craftsman extraordinary control over every stroke. The shavings that come off a kana in skilled hands are nearly transparent, fine enough to read through. A joint cut to this tolerance holds without glue because the wood surfaces are in such close contact that the fit itself becomes the fastener. To add even more strength to the geometry, running through the frame of a traditional Japanese timber structure is also a system of horizontal beams called nuki, which pass directly through the vertical columns. They are held by the wood around them rather than bolted rigid, and this allows the entire frame to flex as one unified system when the earth moves. The wood was always going to move. The question was whether you fought that or built around it, and would that philosophy work? It did. Because in the Japanese countryside near the ancient city of Nara, there is a wooden building that has been standing there since the late 7th century. It is called Horyuji, a Buddhist temple complex traditionally said to have been founded in 607 AD by Prince Shotoku and rebuilt after a fire in 670 AD. It contains a 5-story pagoda and a main hall that together form what historians widely consider to be the oldest surviving wooden structures on Earth, still standing in one of the most earthquake-prone countries on the planet, through 13 centuries of storms, fires, and shaking ground, built with almost no metal fasteners at all. The mortise and tenon joints, the kana cut precision, the nuki beams flexing within the columns, every connection in that building has been responding to earthquakes for over 1,000 years, spreading the force, absorbing the energy, returning to position. But the carpenter who brought that philosophy understood something the building itself could never demonstrate alone. There is something that can disappear far faster than any wooden beam: the knowledge of how to cut the joint in the first place. The judgment that tells a craftsman when the wood is ready, how the grain will behave under load, and how much taper to add so the fit tightens without splitting. That knowledge can't be written down in any useful way. It only transfers through watching someone do it repeatedly over years. In the relationship between an experienced craftsman and an apprentice watching the same cut made for the 100th time. But hands age and masters retire. In a single generation, knowledge that took centuries to build can simply cease to exist. Horyuji answered the earthquake problem. What nobody had solved yet was how to keep the knowledge of how to build it from dying with the people who knew. In a forested valley in central Japan, there is a shrine called Ise-jingu, and every 20 years, workers tear it down, because if they don't, something far more important than the building will be lost forever. Adjacent to every major structure at Ise-jingu is an empty plot of land, gravel-covered and carefully maintained, exactly same size as the building beside it. Every 20 years, construction begins on that empty plot. A complete new shrine is built from scratch. Same design, same materials, same joinery, while the existing structure still stands. When finished, the sacred tools and knowledge are ceremonially transferred and the old structure is dismantled. Its timber is redistributed to other shrines across Japan, where it continues serving as building material for decades more. This ceremony is called the Shikinen Sengu. It has been completed more than 60 times since the late 7th century. The practice is credited to Emperor Tenmu and was first carried out under Empress Jito, though the earliest details remain unconfirmed. The timber isn't really the point. What matters is that every rebuild puts older craftsmen and younger ones on the same site, doing the same work together. Every cut, judgment call, and instinct about how wood behaves under load is passed directly from experienced hands to new ones. A craftsman who apprenticed on one rebuild will be a senior craftsman on the next, and a master by the one after that. The 20-year cycle is designed almost perfectly to a human working life, long enough that skills are deeply embedded before transmission, and short enough that the transmission always happens while the knowledge is still alive. The building is just how the lesson gets passed on. It worked for a long time, until the thing that broke the cycle wasn't an earthquake or fire, it was a war. The Sengoku period, a prolonged era of civil conflict in the 15th and 16th centuries, broke down the cycle. For over a century, the resources and stability required to carry it out could not be sustained. The shrine fell into disrepair and the cycle was interrupted, but the knowledge survived. It eventually resumed, and that is a testament of how deeply the obligation surrounding it was felt. Then came the 20th century, and the threat that nearly ended everything arrived as an economic argument. Steel and concrete were cheaper and faster. They didn't require any of the decade-long training traditional joinery demanded. So workshops closed and masters retired with nobody waiting to replace them. The knowledge that had outlasted 1,000 years of earthquakes came closer to disappearing in a single generation of economic pressure than it ever had from anything nature could manage. The workshop lineage the Pekchik carpenter had founded and grown into Kongo Gumi, widely regarded as the oldest continuously operating construction company in the world, with a documented history stretching 14 centuries. In 2006, following financial difficulties, it was liquidated and absorbed as a subsidiary by the Takamatsu Construction Group. It still operates today, but as a subsidiary rather than an independent company. The Shikinen Sengu could not be canceled. The craftsmen had to be found, trained, and set to work. That's the backdrop for what's happening in Yamanashi, and for a small company that's still willing to build the slow, difficult way. Sobokuya's 8 motto was completed in August 2022 in Hokuto City, Yamanashi. It sits on a steep, forested site with a large roof that extends beyond the interior. Part of the roof structure uses kanawatsugi, a traditional scarf joint, so sections of timber can be joined without bolts or metal fittings. The building also uses a stone base approach, where pillars bear on natural stone rather than being fixed to a concrete slab. 2 months later, they completed Garden House. an 85 square meter home in the same region. Its frame was built using the traditional kagumi post and beam method, with natural timber and white plastered walls designed around the four seasons visible through large windows. It is a house where the structure itself is the finish. Yet at this level, kagumi is rare today. Only a handful of workshops like Sashikan, Tategu, Koge, and Sobokuya still build this way because it takes years to master and simply doesn't scale like modern construction. When engineers and architects eventually looked up from the concrete century and examined what had nearly been lost, they found a system that aligns closely with challenges modern construction is still working to solve. How do you build a structure whose components can be fully disassembled and reused? Issei Jingu has been doing this across more than 60 cycles. How do you create connections that perform under seismic load without rigid metal fasteners? Ryuji has been demonstrating the answer for 1,300 years. How do you design a building that maintains its integrity over time rather than degrading toward demolition? The Shikinen Sengu answers this with a better question. Do not ask how long the building can last. Ask how long the knowledge of how to build it can last, and then design a system that keeps that knowledge alive. Architects and engineers are still chasing most of what those buildings figured out over 1,000 years ago. It all goes back to a carpenter from Pekchik who crossed the sea, decided not to go home, and started teaching. And in places like Yamanashi, that kind of teaching still happens in the most direct way possible, by building. It isn't a single grand project so much as steady repetition, with each job passing the craft forward.